Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to compute exponential expressions on integers and fractions, and how to perform basic exponential operations and recognize like terms. How are we learning it? Through the Exponents Notes and the Exponents assignment. When can we use this? To calculate the amount of money in a savings account, including interest. How do we know we learned it? By getting a score of 4 on the Exponents assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. Next, we'll do our weekly raffle. After that, we'll go over the Exponents Notes, and then I'll give you time to complete the Exponents assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the exponential function study guide and any incomplete assignments that you may have. Let's take a look now at the Exponents Notes. Our notes begin with the learning goals and success criteria. Now, what is an exponent? An exponent is a number that tells you how many times to multiply the base number by itself. So for instance, we have 2 to the third power. 2 is what we call our base number. And it tells us that we're going to multiply 2 times itself 3 times. So that's really 2 times 2 times 2, which is 8. Now let's talk about positive exponents. So positive exponents mean that the number above here, the number of times that we're going to multiply it times itself, is a positive number. So we have 5 squared. Well, that means that we're multiplying 5 times 5, which in this case is 25. Then we have 5 to the third power, which is 5 times 5 times 5, which is 125. And then 5 to the fourth power is 5 times 5 times 5 times 5, which is 625. So we can do this with any exponent. We can take any base number and raise it to an exponent and multiply it by itself a certain number of times and solve. Now what about 0 and 1 exponents? So 5 to the first power. Well, 5 to the first power is just 1 5, right, times itself, so 5, that's it. So that's just 5. Now, 5 to the 0 power. So there's 0 5s, and that's equal to 1. Now, please make sure that you understand this. Any number raised to the 0 power will always be 1. So not 0, but 1. So 5 to the 0 power is 1. 2,000 to the 0 power is 1. 200 million to the 0 power is 1. So any number raised to the 0 power is just 1. Now combining like terms, if we look at this, we're going to combine like terms, and the rule is in order to combine like terms, they have to have the same exponents and same variables. And if they do, we're going to add the coefficients. So for instance, we have 2x and x. Well, they're both x's, so they have the same variables, and they have the same power, same exponent. Really, it's imaginary exponent of 1. So we can just add these. 2x plus x is 3x. We have 3x squared plus 4x squared. Again, same variable, they're both x's. And the powers match, so we just add the coefficients. That's 3 plus 4, which is 7x squared. We can do it with subtraction as well. So we have 6x cubed minus x cubed. Well, again, same variable, same power. So now we can go ahead and subtract. So 6 minus 1 is 5x cubed. Now we have 7x to the fourth minus x cubed. Well, again, same variable, but this time they do not have the same power, so we cannot combine them. It just stays 7x to the fourth minus x cubed. Now, when we multiply or divide exponents, so the rule is this. When we multiply or divide exponential terms, even if they do not have the same exponents, but have the same variable, we can still do it. The rule is we multiply or divide the coefficients and add or subtract the exponents. So if we're multiplying, we're going to add the exponents. So this is 2 times 1, so that's my coefficient. And I have an x to the first and an x to the first, so I'm going to add those exponents. So I get 1 plus 1 for my exponents. So 2 times 1 is 2, And 1 plus 1 is 2, so it should be 2x squared. Let's look at another example of multiplication. So we have 3x cubed times 4x squared. Now with this one, again, we're going to multiply the coefficients, so 3 times 4, and we're going to add the exponents, so 3 plus 2. We end up with 3 times 4, which is 12, x, and 3 plus 2 is 5, so we get 12x to the 5th power. Now division is just the opposite, so we're going to divide the coefficients and subtract the exponents. So we get 6x to the 7th divided by 2x to the 3rd, so we're going to divide the coefficients, so 6 divided by 2, and then subtract the exponents, so it's x to the 7 minus 3rd power. So 6 divided by 2 is 3, and 7 minus 3 is 4, so we get 3x to the 4th. Now here we have 7x to the 4th divided by x cubed. So again, we're going to divide 7 divided by 1, and x to the 4th minus 3, which is 7 divided by 1 is 7, and x to the 4 minus 3 is first power. And whenever it's the first power, we don't need to put it there, so it's just 7x. Now what if we have the coefficient and variable inside of parentheses and the power outside? Well, when we do that, we're going to raise the power by multiplying the exponents. So in this case, we have 2x, and this is x to the 1st, and we're going to multiply the powers for each of these. So this is really 2 to the 1st power times 2, and x to the 1st power times 2. So that's really 2 squared times x squared. Well, 2 squared is 4, and x squared is just x squared, so it's 4x squared. Let's look at this one. Again, same thing. This is 3 to the 1st and x to squared. So we're going to multiply each of those by the power out here, which is 3. So we got 3 to the 1st times 3 and x to the 2nd times 3. Well, we know that 3 to the 1st times 3 is 3 cubed, and 2 times 3 is 6. So we got 3 cubed times x to the 6th, and 3 cubed is 27. So it's 27x to the 6th. Now for this one, we have x squared times y cubed, and we want the whole thing squared. So again, we're going to multiply it. So x squared times 2, and y to the 3rd times 2. And we get x to the 4th, y to the 6th, because we multiply 2 times 2 is 4, and 3 times 2 is 6. Now we have x, y squared, z cubed to the 6th. So we're just going to multiply each of the exponents by 6. So we get x to the 1st times 6, and y to the 2nd times 6, and z to the 3rd times 6. And we're just going to multiply these out. So 1 times 6 is 6, 2 times 6 is 12, and 3 times 6 is 18. So we should get x to the 6th, y to the 12th, z to the 18th. Let's take a look now at the exponents assignment. So our assignment here begins with our learning goals and success criteria. If we scroll down, we begin our questions. So the first one says, what is 3 to the 3rd power? Well, 3 to the 3rd power is 3 times 3 times 3. Well, 3 times 3 is 9, times 3 is 27. So we'll go ahead and mark that as our answer, 27. And we'll scroll down to the next one. Next one says 2 to the 4th power. Well, 2 to the 4th power is 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 again is 16. So 16 would be my answer. And I will continue to answer these all the way until I get to the end. Once I get to the end, I'll click Next. And then that'll take me to my Before You Go. Fill out your Before You Go, and then submit your work on Google Classroom.